All right, so today we talked about determining if a relationship or a relation is a function. And before we did that, we talked about independent and dependent. And just as a quick reminder, your independent are your x values. They are also the domain of a function, and is also the input values. And this is where our function information will come in handy. The independent values happen first. Okay, and they are also almost always described by time. Okay, or anytime you see time given in a situation, that is almost always going to be your independent values. Your dependent values are described by the y-coordinates. It is also the range of your function. It is the output of your function. Okay, the dependent values depend on on what happened first. Okay, and usually it's a total. If you're looking at a situation, it's usually a total amount. Okay. All right, so remembering that your independent values are your input, your dependent values are your output, we talked today about functions. And a function simply is where you have one input and that one input has only one output. Let me make an arrow here because it doesn't necessarily equal, but one input maps or goes to exactly one output. So if we look here at this relation of coordinate points or of ordered pairs, if you look here, our input is our x values. So we're looking at a 4, a 6, a 3, and a 5. Since none of our x values repeat, we know then that each of our inputs will have exactly one output. And so we can say that this is a function. Now if you notice, these sets right here, the input of 6 and the input of 3, both have an output of 2, but that's okay. It doesn't matter if the output is the same for two different inputs as long as your inputs are different. Okay, so let's look here. This is called a mapping. This is maybe a new diagram for some of you. Remember, the inputs are here on the left. And your output values are on the right. Okay, so if we put a 4 into whatever our rule is, our function is, a lot of times functions are rules, we would get out a -2. If we put in a 6, we get out a 3. If we put in an 8, we get out a -2. So whatever our rule is, those are our outputs. Now if you notice, each of our inputs is unique and each input has exactly one output, so this also would be a function. All right, if we look at this graph right here, we can determine if that's a function as well. And we talked about doing the vertical line test, because if you do the vertical line test, let me change colors here. If you do the vertical line test, looking right down here, we're drawing a vertical line along, that's not really vertical, but you know what I mean. If we're doing, there we go. Okay, you notice that your graph only touches that vertical line one time. Okay, so that means for this x value of x is x is a +2, it only has one y value of, it looks like a 1, 2, 3, 4, 5, 6. Okay, so one output. The input is the x values, the output is the y values, and each of these x values only have one y value, so yes, this is a function. Let's look again here. I've got some ordered pairs. I've got a 4 as an input, a 6 as an input, a 5 as an input, and a 6 as an input. So here I notice that I've got repeating inputs. Okay, they each have a different output, so this would not be a function. Okay, that means we cannot have a good rule that would demonstrate where you input a 6 and you get out only one output. Okay, when you input a 6 you could get out a 3 or you could get out a -2, so that does not demonstrate a function. Alright, let's look at this mapping here a minute. My input is a -3, I get out a 1, I also get out a +3, so this right here tells me that I have two outputs for this one input, so that is not a function. That does not demonstrate a function relationship. Let's look at this graph. Let's use our vertical line test. There, my vertical line touched the graph in two spots, so that means for my input value of a -2, which is my x value, I have two y values for that one x value. Here I can see it again. I can check with this vertical line test. For my input, my x value of a 1, I come up with an output of a 2 and a -2, so this would not be a function.